Hello, everybody. I just want to uh, tell you about tolerances and fits because I forgot yesterday, or actually I didn't see that you have a question on this topic as well. So I'm just going to brief quickly what tolerance and fit is. So let's see. The term tolerance is the difference between maximum size and the minimum size, or you can say that it's the difference of dimension between maximum and minimum size. So for example, look at this diagram, the picture. So these are the parts that manufactured in a company, the things that parts are manufactured in a company, and this is the actual size we need, the actual size given in specification. But after manufacturing, parts can be this size or this size or different sizes. It doesn't fall on the actual size. So we will set a range of parts that can be accepted. So if a part is smaller than this range here, then it will be rejected. So if the part is higher than this size or the dimension, this will be, that part will be rejected. So whatever the part falls in this range are accepted as good for sales, like that. So in quality checking, this is what happens actually. So what I just want to tell you, highlight this word tolerance. It is a difference between maximum and minimum dimension of the component. Okay, so here you have the definition here. You can remember this. So also you can say it's the allowable variation. So engineering tolerance refers to the allowable variation of differences between actual dimension you can say. So the allowable variation is this, that is the tolerance of the production. Um, Actually you have two different types of tolerances. You have bilateral tolerance and unilateral. Right now you don't have to remember this. I'm just saying you. So this is the size that we specify at uh, zero, I mean baseline, and if the tolerance sizes are over these, like on the baseline or the above the baseline, we call it unilateral, and on the like in between the maximum and minimum sizes, then it's we call bilateral. uh, and you have seen on engineering drawings, this type of tolerances are given. We will learn later on about this. So in engineering drawing, it is very critical to indicate tolerances, because sometimes these can part are like say nut and bolt standard sizes. So the different company will manufacture nut and the bolt will be in a different company. If the size is not in this range, I mean the given tolerance range, nut and bolt cannot be fit. So that kind of thing, we have to specify minimum and maximum value of the tolerance. So this also like made in two part. So if we don't indicate tolerance, this may, because we cannot manufacture it to actual size, there will be some variation. So we will give a small allowance, and to this is a shaft goes in this to hole. So if this shaft is diameter is high, we cannot insert in this. So in assembly operations, very important indicating tolerances. So I was saying why tolerance indication is important. So one reason is it is easy to interchange with parts, and other I told that it's easy to like properly fit for hole and shaft. And manufacturing feasibility is important, because if the tolerance is indicated, it is easy to recognize which machining process we should take. So in some machining, like in grinding processes, like the variation of the uh, dimensions are very low, but if you are doing hand sew or like piling, the variation is very high. So which, according to this, we can identify which parameter, which process can be used, and this is need for reduce cost of design or design optimization. So remember the why it is important to indicate tolerances, and also this term fit. So this is like assembly of shaft and a hole. We will talk about this some other time. Just remember there are three types of fit. So we are talking about shaft and the hole. So when this is the hole and this is the shaft, when you insert the shaft into the hole, when if it is loose or if there is a free space, the shaft will easily goes in. So for that type we will say clearance fit. And types of and another may be hole and the shaft. When we insert it, it is very tightly, or like you can insert but it's tight, we can call it's overlapping or the transition fit. So the clearance between minimum and maximum of both shaft and almost same. It's kind of same size. So the other type is interference fit. In interference fit, maybe the shaft dimension is more than the hole dimension. So when you are inserting this, some material of hole will be removed, and it will be very tight. You have to use kind of press machines for fitting these kind of fits. So these are three type of fits: clearance fit, transition fit, and interference fit. Remember this as well. So I will stop here, and remember what I asked you to do. Okay, thank you.